Wiring materials that we need for this job here is the low voltage circuit board off the old air handler. We're going to need a little transformer, 115 volt. This is a 20 VA, really small, compact, because we don't need very much. Here is the line voltage connector with the jumpers installed. A power cord off an old computer or another way to grab these, and a toggle switch. This is a single pole double throw. This is going to be how we select 3 different speeds for the fan, and the way I wire this is off. As soon as you plug it in, it's going to power the transformer up, and it's going to energize the green speed, which will be low. So off off on the switch is low. As soon as you plug the fan in, is going to be a G call. Now we'll call that low. We'll call one set of contacts medium, and we'll call another set of contacts high. And every board is a little bit different, so you may use low as Y1. You may use low as yellow. You may use high as a W heating call, because sometimes the speeds are different, and you can also do a lot of different things by setting up the dip switches for the different units that this motor is programmed for. You also don't have to use this particular circuit board. Like, I could use a carrier board I saved off an old carrier, because all the programming is inside here, and these are mostly the same. So you'll be able to select your different speeds. You know, let's say you wanted to do a different speed than what you've got low, medium, high. You can open this up, change your dip switches, and you can get a myriad of speeds. I like these control boards because it has a CFM indicator light, whereas the other ones, if you don't have it, you're kind of guessing. You can also use this kind of a board as almost a test or a setup board, so you can count your CFMs, you can see what the motor's doing, and then you could actually switch it to a board maybe that doesn't have a light, and that way you can still know what it's doing. But so that's basically all the wiring materials you need: power cord, low voltage board and harness, of course, high voltage harness, transformer, toggle switch. You also need some sort of cabinet to mount these all in, and this is the Rheem counter. I'm probably going to screw that right to here, and this transformer should fit in there nicely. This board should fit in there nicely, and I may make like a cover plate for that. That should screw right here and have all my wires inside the box. And yeah, so a box is nice. You wouldn't want this just, you know, dangling out there to get messed up. So yeah. Okay, so we're on to part 2. What I've done is I've taken all the original controls out of this Rheem control box. That's why I like to save little control boxes like that for these kind of projects. It makes it nice to have something pre-made. So this is the fun part. This is the part that I enjoy. What I'm going to do is probably use this tie strap, maybe a couple others, to secure the wires like that. The ground's going to just land on the cabinet somewhere neat. Let's bring our high voltage connections up in here, and we'll be tying those in with the transformer. And our these are our low voltage air handler speeds, and what I did was just remove a lot of the ones that I don't need out of this connector to keep it simpler inside here. So here's the wiring schematic. Of course, take the secondary side of the transformer and power up this control board just like it used to be in the original air handler. So it's real easy. You got red and you got blue going to the board. Now these are the low voltage signals leaving the air handler to the thermostat, and these are going to be how we control this motor. The wiring plan is like this. Red and green are always going to, it's always going to be calling for green. Anytime you plug it in, it gets a call for green. And that's where this single pole double throw switch is going to come in. We're going to mount this toggle switch right here at the top. In the middle is basically off on the switch, but that's how it's low, because it's always calling for low whenever she's plugged in. Now on one side of the contacts is going to be my white wire, heat strip speed. My other set of contacts is going to be yellow. So what we'll do is in the middle will be low, one set of contacts high, one set of contacts medium. So that's kind of the plan, guys. It's pretty straightforward. It's not that hard. So yeah, I'll keep working here and bring you guys along for the next stage. I had to rotate the motor around to make these fit. That was one little thing I forgot to do. And this cover will fit on here like so. Okay, these wires will all be inside, and this switch I'll make a hole for this switch on top. May figure something out to cover that, I'm not sure. So okay, the line voltage wiring is done. We've got white in from the cord, neutral in from the cord, to line 2 on the fan to the transformer. Same with the hot lead, transformer, cord to the motor. Ground wire is landed here. So my low voltage, the red, green, and the second red lead are all tied together there. And now I'm going to crimp these round stake-ons on there. And I wanted to show you guys a little trick for these crimp ends. I had a buddy of mine show me this, and I've done it this way ever since. Most of them have a little split. Now when we crimp this wire, we're going to take the pointy end of our tool, we're going to line it up with the crimp. Okay, so the first thing we're going to do is just start to fold those two in on itself. Just like that. You see how it rolled those over? Then we take the flat part of our pliers. I like to do it right here. And we finish off the crimp by smushing those two together. And that's how I like to do my crimps. Hope you guys can see that. I hope it came out. So again, you take your pointy end and you smush down on the split, and then we follow up by folding it over and compressing it. You can do that on insulated ones. Again, you look for the split, you can line up the top. I don't know if I can do this for you guys can see. Put it down nice and tight. Yeah, that kind of messed up the insulated part, but you guys get the general idea. Good solid crimp connection. Okay, so we've got our switch wired in. And just thought I'd show you guys that. And I also pulled the sticker. Ended up using a train motor. You guys may have noticed that, obviously. But I stuck the sticker on here, and you guys can see this is out of an 049 unit. So these are all our settings. And that's one thing that may change from model to model, whether you use yellow for medium, white for medium. Usually green and red is always going to be the low. So the center position or off on the switch will be low, medium, high. And so it's really nice just by flipping these dip switches, you can change it. You can go all the way up to 2000 CFMs, you could do 1200. You've got your heat strip settings here. And then you've got your G, your fan only speed, which should be usually low. So nice and adjustable. You can set it up if you want more air, if you want less air. You can change it real easy. Okay, everyone, here's the wiring all finished. Got my switch installed in the housing. Got the wiring done and zip tied. I'll probably add another strain relief to the cord here. But it's done temporarily, so I know what we're all waiting for. A test run. So let me clear off some of my tools off my bench here and we'll give it a test whirl. Let's see, it looks like we're set up for 1 on, 2 off, 4 tons, 3 on, 4 off. Wow. I'm sorry. Yeah, 3 on, 4 off, high 450. Wow. Okay. So that's going to be pretty high airflow. That's going to be like 1800. And our heat strip speed 7 off. Heat strip speed 1700. So let's make our yellow be like 1000. Well, let's make it be 1200. So let's do 3 ton, 1 on, 2 on. One on, 2 on, 3. We'll do low, 3 off, 4 on. Okay. Alright, so I got it set up. We should do about 1000 in medium. We should do roughly 500-600 in off, and 1700 will be high. So let's give her a whirl. Alright, we're gonna plug her in. You guys will be my witness to what's gonna happen here. Let's do safety first to make sure nothing's energized. Looks like we're safe here. Okay. Cool. Alright, so let's see what we got. Let's count our blinks here. 1, 2, 3, 4, 5, 550. Alright, let's switch it to yellow. 1, 2, 3. So like 11. Okay, let's do heat strips. Oh yeah. That's a lot of air. Success. Well guys, I got it all done. I was doing final touches. The grill, had to do some modifications to it to stiffen these vanes up, make them stay in one place, and also stuck this screw in here too. It won't fully shut. And you can see I had to use some of my framework to attach the grill. It's pretty solid. I put this little piece up here to stiffen this top frame up because that's kind of where you almost want to grab this thing from. Got the wheels on it, but there she is in all her glory. Model R2D3. This is the third one I built. You guys want me to plug it in so you can see it work? Got a nice long cord on it so you can plug it in. So we're starting in low here. That's low speed. We can make the air go up like that. Blow up to an attic. We can make it come straight across. Come out the front. Let's do medium. Medium. That's 1200 CFMs. Going straight up. You can make it come out front here. It's too high. The high is 1700 CFMs. Okay guys, that pretty much wraps up this little project here. I think you guys, one last little detail is put some of this hardware cloth over that opening there so nothing gets sucked into it. But I'll do that. You guys don't really need to see that. Hopefully I got most of the part you would need to try and make one of these yourself. I think you guys would be impressed with how nice it works and all that. So leave me a comment. Let me know what you guys thought. We'll see ya.